Number 40. Yeah, forte. Okay, it says find a number of distinguishable permutations of the group of letters. Now, this is an important word right there. Distinguishable. Okay, that means different. All right. In other words, look at all these B's as if they're different B's. If you switch two B's, is that distinguishable from what we just had? The answer is no. It is not distinguishable. And so what we got uh, right here is an arrangement of the letters. Okay, and I can rearrange all those B's, those three B's, and I can rearrange all those T's. Let's just talk about the B's first. Okay, I'm gonna give each B a name so that that's kind of funny. Uh, I'm gonna give each B a name so that I can see all the different ways that I can reorganize them. Okay, I'm just going to list them out really quick, and then I'll show you guys the faster way to think about it. So this is one way to list them out, or I can have the 3 be second, and then the 2 is last. Or I can have the B sub 2 be first, and then the B sub 1, and then the B sub 3. B sub 2 can be first again, but the B sub 3 would be second, and the B sub 1 would be last. We have two more that we can write out. All right, so let's move those up a little bit. Now let's say B sub 3 is first, B sub 3, then B sub 1, then B sub 2, B sub 3, and then B sub 2, then B sub 1. Okay, so how many different ways can we rearrange just the B's? 1, 2, 3, 4, 5, 6 different ways. We can arrange those B's 6 different ways. And so how do we, is there a faster way to do that? Yes, the answer is yes. See, let's think about this a faster way. There's 3 spots because we got 3 B's. How many different ways can we rearrange those 3 B's? Well, for the first spot, there's 3 B's possible to go there. And then 1 B goes away, and in the next spot, there's only 2 B's that are possible to be there. And then the 1 B goes away, and there's only 1. Okay, and hopefully you guys can see this now. You can choose 3 times 2 times 1 is 6. You can rearrange those B's 6 different ways, and this works for any number of letters. So what is 6? Well, it's 3 factorial. This is the same as 3 factorial. Okay, what about the T's? There's 5 T's. Yeah, there's 5 T's. I'm looking at the T's. There's 1, 2, 3, 4, 5. So that means there's 5 spots. How many different ways can you arrange those T's? And so since there's 5 spots, 1, 2, 3, 4, 5. It would be 5 of them, then there's 4, then there's 3, then there's 2, then there's 1. Hey, that's the same as 5 factorial, which is the same as some kind of big number. 5 times 4 is 20, times 3 is going to be 60, times 2 is 120. I knew that was a nice one. So 120 different ways you could arrange the T's. Okay, now why is this important? Why do we need to know how many different ways we could arrange the B's and how many different ways we could arrange the T's? That's because we don't want to count each of these as different, because they're not distinguishable, which means they're not different. They're the same, because we can see their difference because we put numbers to them, but up here there's no numbers to them. Those B's are the same essentially, and so we gotta not count those B's. And so for this exact arrangement, there's actually 6 times 120 different ways you can arrange the B's and the T's to get the same arrangement, and they wouldn't be distinguishable. See, 12 times 6 is 72. So there's 720 ways we can have this arrangement, and we can't count 720 ways. Okay, so this is what we got to do. Let's consider how many total we got. We got 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total numbers, which means there's 8 factorial ways you can rearrange those numbers. But because there's this many ways to rearrange the B's, and this many ways to rearrange, or this many ways to rearrange the B's, this many ways to rearrange the T's. We got to take those guys out. So we would say 3 factorial and then 5 factorial. And I think you can see where we get the 3 and the 5. We get the 3 because there's 3 B's, and we get the 5 because there's 5 T's. And so once you figure this out, then you win. You're done. Okay, so 8 factorial, let's split this up. 8 times 7 times 6, and I'm going to stop right there and put a 5 factorial right there. 3 factorial and 5 factorial. The 5 factorials go away. Okay, that's why I stopped at 5, because I could see that I could cancel those out. And then the 3 factorial, we know equals 6, or you can write it out 3 times 2 times 1, and then you can cancel out the 3, then the 6, and then the 2, then the 2. Or you could have just went 3 factorial and 6 and cross those out. So the total number of distinguishable ways to rearrange those letters in this problem would be 8 times 7, which is 56. That's it. So you have to do the number of letters factorial, which was 8 factorial, and then you have to take out all the repeats, okay, which is what the dudes are on the bottom.